Hello, grade 12s. Let us look at the June 2025 metric examination for the chemistry. All right. Now, we're given here the graph below shows the concentrations of nitrogen, hydrogen, and ammonia against time for the reaction. All right. Against time for the reaction, we're given the reaction there. Our reaction is nitrogen plus the 3 mole of hydrogen to produce 2 moles of ammonia. All right. We're given that this reaction here is exothermic because delta H here, we can see delta H is less than 0. So whenever you're having delta H less than 0, we know that the forward reaction here is going to be exothermic. It's going to be exothermic. It's going to be exothermic. It's going to be exothermic. The forward is exothermic reaction. Now they want us to look at time intervals T1, T2, and T3. This is the concentration versus time graph, right? The question says here, which is the correct representation for each time in the graph? Let's look at T1. Let's look at T1, guys. I want you to look at T1, time interval 1. There is here, I want you to look at the concentration of hydrogen. It gently decreases, all right? And how about the concentration of ammonia? It gently increases here. It gently increases. But there is a sharp increase in the concentration of nitrogen. Look at the concentration of nitrogen. It sharply increases. It sharply increases here. This is the concentration of nitrogen. It sharply increases. That's what is happening there. It sharply increases there. So whenever you're having a sharp increase and other graphs are gentle, just know that this is concentration. That's how you see concentration, the effect of concentration, all right? But is this a decrease in concentration or an increase in concentration? This is an increase in concentration because this is a sharp increase in concentration. That's what is happening. There's a sharp increase in concentration. Other graphs are gentle, right? Other graphs are gentle. Other graphs are gentle, but there is a sharp increase in the concentration. This concentration here sharply increases. All right, so this is an increase in concentration of nitrogen. So our answer there, so we're going to say the concentration of nitrogen increased. Let's go to time interval 2, right? Time interval 2. We can see here, the new equilibrium is reached here. The new equilibrium is reached, established. The new equilibrium is established. And then there is a disturbance. Look at this. All graphs increased here. Look at that. All graphs increased here. All right, at time interval 2. At T2, all graphs increased. Whenever you see all graphs increasing, just know that this is an increase in pressure. All right, so this is an increase in pressure here. This is an increase in pressure. So there is pressure increased at time interval 2. All right. Now let's go to time interval 3. At T3, what happened? Look at T3. All graphs are gentle. So look at the concentration of nitrogen. It gently increases, right? It gently increases, then it reaches equilibrium. And look at now the graph of ammonia. It gently decreases, all right? Then it reaches equilibrium. How about here? How about the graph of hydrogen? It gently increases, then it reaches equilibrium. So all graphs are gentle, right? We don't have a sharp increase, right? All graphs are gentle here. We don't have a spike. Just know that this is temperature. So here, the concentrations of the reactants increase. Look at that. The concentration of nitrogen increase. I want you to look at this. The concentration of nitrogen increases, and also the concentration of hydrogen increases, and also the concentration of hydrogen increases, but only the concentration of the product decreases. The concentration of the product decreases. The concentration of the ammonia decreases. All right, but we know that the system shifts to favor the reverse reaction. All right, the system will favor the reverse reaction, which is the endothermic reaction. All right, so the reverse reaction here will be favored. So the reverse reaction is endothermic reaction because the concentration of nitrogen and the concentration of hydrogen will increase. Can you see that the reverse is favored? So the endothermic reaction is favored. So according to Le Chatelier's principle, increasing the temperature favors the endothermic reaction to absorb the extra heat. So which means now the temperature is increased there, all right? Because the endothermic reaction is favored.